I want you to imagine a situation now. A girl goes out for shopping with her parents. They have plans of buying vegetables, groceries, a TV, and a home theater. The girl observes a tag hung to every product. Could you find out what was that? Yes, that's the price tag. It was hung on a 10 kg sack of rice, the heap of vegetables, on TVs, and even on home theaters. But the figures mentioned were very different. Vegetables and rice usually have a price range which goes up to 4 digits and not more than that. But TV and home theaters, as you all know, don't even start from a 4-digit number. The girl got really confused as to how to read those bigger numbers. In your previous classes, even you would have learned about numbers up to 4 digits, isn't it? Now, let's recall what all have we learned about numbers. To start with, the smallest 2-digit number is, can you guess? Yes, it's 10. And the greatest 2-digit number is 99. Right? Did you all remember? Yes. Now, how do we go further ahead? When we add 1 to 99, we get 100, which is the smallest 3-digit number and is read as 100. And 100 is supposed to be the smallest 3-digit number. Now, can we go on like this? Let's try. The greatest 3-digit number is 999, which is read as 999. Again, when we add 1 to 999, that is 999, we get 1000. That's right. What happens, when we add this 3-digit number with 1, we get 4-digit number. And this happens to be the smallest 4-digit number and is read as 1000. Similarly, numbers go on increasing in the same way and we arrive at the next greatest 4-digit number, which is, yes, that's right, 9999. It is read as 9999. Did you all understand? Now, don't you know what happens when we add 1 to 9999? It's very simple. It goes the same way. Now, we get 1000. That is 5-digit number, which is the smallest 5-digit number. We read it as 10,000. Here the digit 1 is at the 10,000s place. This happens to be the smallest 5-digit number. Okay, now children, can you all recall what all we have learned till now? Yes, we started with the smallest 2-digit number, then moved on to greatest 2-digit number. We dealt with the smallest and greatest 3-digit number. Later, by adding 1, we arrived at smallest and greatest 4-digit number, then smallest and greatest 5-digit number, and so on. If you observe the pattern is the same. Let us take a few examples of 5-digit numbers and try to represent them in words. Will you be able to try along with me? Okay, that's great. Then let's get started. The first example being 10472, which is read as 10,472. Now the second example, 56984. Will you try? It is read as 56,984. Now for the third example, 23498, which is read as 23,498. If you have got it right, then we can move on to the next quick answer questions. Very easy questions to be answered in just a minute. Few seconds is also enough. Which you are supposed to answer this questions immediately, fast as fast as possible. Write the greatest 3-digit number. Write the smallest 3-digit number. Write the greatest 4-digit number. Write the smallest 4-digit number. Now answer the following. This is a quick answer question. Don't take too much of time. First, just think and you should be able to answer these. Write the greatest 3-digit number, the smallest 3-digit number, the greatest 4-digit number, and the smallest 4-digit number. Now for the assignment. Assignment number 1. We will have those the problems which we have already dealt with. The first mean, you have write the following in words. You have 6 problems given. Then the second main, you have write in figures. You have 5 digits being given in words. You are supposed to write in figures. I hope you will be completing this before the next math session. And moving on from this, we can represent a 5-digit number on the abacus. Children, you might have all learned about abacus for smaller numbers. We shall try to apply the same knowledge for representing larger numbers now. The basic rule to represent through abacus is the leftmost spike represents the highest place value of any number. Here the leftmost spike represents the 10,000s place, and the others, if you can observe, the bead here is at the 10,000s place. So this is the highest place value in this particular frame of abacus. So since we are dealing with 5-digit numbers, so we will have the highest place value being placed at 10,000s level. We will take a few examples to understand how it has been represented. Now for the first example, it is 63,219, wherein 6 happens to be at the 10,000s place. So we have 6 beads here. Then naturally the thousands place happens to have 3 beads. So thousands place we have 3 beads. Hundreds place has 2 beads in it because the number is 2. And similarly, tens place has 1 and ones place has 9 beads in it. Now for the next example, it's 70,016. Here if you observe, the highest place value is of 10,000s, which is 7. So I have 7 beads at the 10,000s place, and I don't have any beads at the thousands and hundreds place because the digits what I have in the number 70,016 is just 2 zeros at the place value, thousands and hundreds place value. So I don't have to have any beads there because the place value of 0 is 0 there. Then tens place I have 1 and ones place I have 6 beads. And moving on to another example for better understanding, it's 92,504, wherein I have 9 at the 10,000s place, then 2 at the thousands place, 5 at hundreds place, and 0 beads at the tens place as the digit is 0 there, and at the ones place I have 4 beads. If we move on in the same manner, we get the next greatest number as well in the same way. Here the next greatest 5-digit number is 99999, which is read as 99,999. Yes, you guessed it right. It is read as 99,999. Adding 1 to this 99,999, we get 100,000, and we read it as 1 lakh. And this happens to be the smallest 6-digit number. And if you observe, digit 1 is at the lakhs place. And this also can be represented on abacus. Here if you observe, as I said, the basic rule being the highest position will have the highest place value, and that happens to be at the leftmost spike. So leftmost spike has the lakhs place here. So in the 6-digit abacus frame. So if we just try to understand it with through examples, few more examples. The first example being 270,194, which is read as 2,70,194. Here the lakhs place has 2 in it, so the leftmost spike has 2 beads in the lakhs place value. Then accordingly it moves on. The 10,000s place has 7. Then thousands place has 0, so no beads there. Then hundreds place value has 1, so 1 bead. Then tens place has 9, and similarly ones place has 4. For another example, here at the lakhs position I have 8 as the number, so 8 beads at the lakhs position, 3 at the 10,000s, 4 at the thousands, 5 at the hundreds, 9 at the tens, and 1 at the ones place. Hope you have all understood how to represent numbers on abacus. Before ending today's session, it's time for the second assignment. In this assignment number 2, you are supposed to represent the given numbers on abacus. Just have the frame drawn and have the number of beads which are mentioned here at that particular place value. Okay, that ends this session, children. I hope all of you have understood today's session, and please don't forget to write the assignment before the next math session. Stay home, stay safe. Thank you.